the need of the movie. And so if we know that blacks and whites with hard straight lines going diagonal, if a person very agitated, then in a part where we have a climax, you get really agitated.
So how are you judging that they are agitated?
How?
Yeah, I mean, you've got cameras watching them.
Yeah, we got cameras watching them, and in the beginning we have a 35 pictures that people are evaluating. We go and make them, and they're actually these pictures here, and it's on a site called visualanalysis.com. It's a little survey, so we're having people run through that. And then they have sliders. They say how they feel, and then we're going to add it and try to do more surveys. We have to actually force. We're thinking of buying people like Albert to keep on us to come in and do it, because how do you get people to actually do these kinds of studies? But we need a base of 200 people to make a good study. So yeah, and it's rather difficult. And the best place to do it would be a gallery situation. So we're trying to get this into some kind of gallery. It's kind of a mix between art and so in our engineering, my collaborator is using this model called Fuzzy Cognitive Goal Knit, a story plot planning tool for interactive storytelling. She's developing this particular approach. Provides a temporal hierarchical structure, which is suitable to represent the temporal relationships among different parts of the story plot. And the hierarchical structure allows decomposing complex structure of the plot as well. So this is a picture of her goal net. I mean, it's just a branching system, basically. As artists, we're doing a branching system. She wants, narratives. So we've been struggling quite a bit with this. And we're just coming to understand, every little performance or piece of motion that the person, our character is going to do, we'll call a function call. And then because we have these better animation systems where we can blend different motions, we can have multiple function calls happening, being called from what's it called? A resource, and like a library pool or something, and then the characters will perform appropriately. But bridging between making the character perform as though it knows what has happened before is the challenge, because if you have a character that just perform and kind of lip syncs what it's doing, it doesn't have any relationship to what it said like 5 seconds before, and it's acting, you'll have this discontinuity between the dialogue and the actor. So we're trying to look at making that strong, seamless. So let's see. The rendering. So the sensor system will detect the audience feedback by using an open source computer vision library, OpenCV. It's called OpenCV. It teaches analytics. The audience feedbacks cannot be limited to the number of persons in the audience. Well, it can be, but not limited to the number. So they have to have a limited number of people in the audience, and we'll have to work on trying to understand how different genders work. So, and being in Southeast Asia gives us a little bit of advantage because there's such a diverse number of people there. But some of our studies have showed that actually people do have very similar facial expressions, but what they react to in terms of colors and some symbolic representation, there's probably going to be a lot of research in that area, and so it'll be challenging. But so everybody has seen movies, and everybody's seen horror movies. Everybody kind of reacts to the same kind of things in these kinds of situations where we're running a narrative. So if we drive people down a particular 20 minutes of narrative, I think we can get more feedback, and we have particular things that are supposed to make people feel certain ways. Then I think that we'll be able to pull out actually some data and say, okay, this kind of design works better. But as artists, as a filmmaker and that kind of thing, you kind of know intuitively. So I mean, we could go ahead and do it anyway, but because we have to do it as a study, we're going through these cycles. The current research in interactive storytelling and narrative focus on multiple branching storylines and how the drama manager creates a story path based on them. In existing works, the stories can change interactively with multiple narratives and different endings, but neither in visual appearance nor in performance of the agents. In our project, we're trying to refine both the visual appearance and the acting performance of the actors and the environment. We're trying to achieve this by using templates of acting. We will incorporate motion capture, but we'll also do some procedural acting to procedural motion. There's a lot of studies that have been done of procedural human motion, for instance. So we're going to try to implement that kind of stuff. For 3 different styles: acute style, normal style, and extreme style, and morph between them with different parameters in real time. For instance, if the sensor system detects that females are dominant in the audience, it'll inform the agent engine. The agent engine then might want to change some parameters in its reasoning to make a decision regarding to achieve the goals or the kind of animation which favors females. Then the rendering engine will be eventually informed, which will morph the rendering styles of the environment and include not just the characters, but also the room and the lights and the whole roundness or softness of the whole visual display to favor motivating the person to feel what the movie in particular wants them to feel. So our next challenge, though, is to integrate dialogue with acting. So although the painting out of the paper says, or Richard said, it's Chavez characters, I haven't quite gotten to that point. And we're just, because we have to execute all this animation, we have all the plot planned out, the action, we know basically what we're going to say, but we haven't actually started writing the dialogue or building up the chat engine. So that's where I'm going right now. And I give my acknowledgments and some references to my colleagues over at ETU. And that's about it. I think we just have time for maybe one question, 1 or 2 questions. Go ahead, Prof.
Well, I was going to say that it strikes me that this has big implications for future interactive advertising.
Yeah, we have had some venture people say that they are really interested in that particular. I mean, particularly if something match with be the the pie in the sky for what you want. Yeah, I mean that's
Imagine the whole wall there reflecting collectively what we're doing in the room.
Right.
As a giant screen, where there's another set of people in the other virtual room behind us, behind you, that we can watch if we want to and interact with, wave at, etc.
Yeah. Well, for products, products, and if you want to buy your favorite car and it suddenly doesn't quite look right and it changes, or take a quick scan of yourself, you want to see yourself looking really good. It's almost like it has that Harry Potter stuff, looking at the enchanted mirror. I think that's kind of where our stuff is going, and certainly with that's what you guys are doing. As chatbot authors, you're giving people what they want in a way, and so these visuals hopefully. Thank you.